Alright, in this video we're going to look at this slope field. We're going to create a slope field for this left example, dy dx equals x plus 1. So we're given a function's derivative. It's in terms only of the x-coordinate. And so what a slope field is it's a nice graphical representation of the general solution to a differential equation. Now notice our derivative only depends on the x-coordinate. So for example, if I said dy dx evaluated when x is equal to 1, let's say, that's going to be 1 plus 1, which is 2. So I know an x-coordinate of 1 should indicate that my function has a slope of 2. So x equals 1 is right here. I'm going to put that kind of below. And the way you make a slope field is for these representative points, you just want to do your best attempt at a slope of 2. So like something like that might be good. And notice I'm trying to make them all parallel because no matter what the y-coordinate is, if the x-coordinate is 1, then the y-coordinate is, then the slope is 2. So that was my attempt at making a slope equal to 2. Let me just use a different color maybe for the next one. Let's say x is equal to 2. dy dx when x equals 2. I plug that into my derivative, 2 plus 1. I get 3. Now, it's not the biggest deal if you make, you're not aiming for like the perfectly precise representation of a slope of 3. It just needs to be, steeper than the one in orange, right? That's supposed to be a slope of 2. So if I'm going to do a slope of 3 over here, okay, I'm not going to label all of these, but you just want to make it steeper, right? So as the x-coordinate grows, dy dx increases. And at this moment it's 3, so I'm just going to try to make it like steeper. Okay, and then hopefully you can anticipate when x is equal to 3, you can even do it mentally, plugging 3 plus 1 and you get 4. So it looks like the slopes are growing. I'm just going to try to make it even steeper as best I can. All right, what about at x equals 0? At x equals 0, the slope is 1. Right? Because, sorry, that's supposed to be a 0. At x equals 0, the slope is 1 because 0 plus 1 is 1. So that's like a nice diagonal. So everywhere I'm drawing a slope of 1. How about at x equals -1? Notice there the slope is 0, right? The slope is 0, so everywhere I'm drawing horizontal tangents. Okay, how about at x equals -2? If you plug that in for x, you get -2 plus 1, which is -1. So that's a slope that looks like this. And lastly, how about when x is -3? When x is -3, -3 plus 1 is -2. So I just need to indicate a slope that's negative and steeper than the one at when x is -2. So this will probably do. Because you're kind of just looking for an overall pattern here. Right? So this is kind of representing the family of curves whose derivative is x plus 1. Now this differential equation is solvable. Okay, so in a different video we've talked about solving a differential equation. So let's find the general solution. The general solution to this differential equation. Oops. So I'm going to separate the variables. Dy equals x plus 1 dx. Okay, we introduce this symbol kind of to indicate we're taking an antiderivative. Antiderivative of dy of 1 dy is just y. Antiderivative of x plus 1 with respect to x is x squared plus x, and then I put a plus c. There's my general solution. Okay, and so, the general solution, you can't draw it in. The slope field is the kind of a representation of the general solution. All right, and so to see that better, I'm going to use a little Desmos, kind of a clear slope field. Typically, if you're here watching for the AP exam, you don't have to. You're probably not going to have to do this many points, to make a slope field. They give you a reasonable amount to do if they're assessing this. More likely it would be a multiple choice, and you have to figure out clever ways to match a differential equation with its slope field. But let me just show you what I mean. Here, so there's a slope field in Desmos. I've got a nice. Oops. Here we go. I'm gonna go over to this. Nope. Apologies. Push it off to the side. Just want that to get out of the way. Finally. So here we see it, right? This is a slope field generated by Desmos. And I've got, that's the same slope field we came up with. And as I move the C in our general solution, you can see that every curve here is basically following the trajectories that we see. All right, so depending on what your C is, it'll go through different points. Okay, but there is our slope field in our general solution to the differential equation, which bring this back now. Okay, so there's an example of making a slope field and our general solution to that differential equation.